have seen three methods of solving differential equation of the form dx by p is equal to dy by q is equal to dz by r. Now let's see one more problem. So this problem says find the integral curves of the equation dx by y plus alpha z, which is equal to dy by z plus beta x, which is equal to dz divided by x plus gamma y, where alpha beta gamma are constant. So solution. So using the multipliers, I'm taking three multipliers. Using the multipliers a comma b comma c, not all zero. Ratios in 1 is equal to ratios in 1 means in this equation is equal to a dx plus b dy plus c dz divided by a into y plus alpha z plus b into z plus beta x plus c into x plus gamma y. Now this is nothing. This is equal to a dx plus b dy plus c dz. Now combining the terms for x, we get with respect to x, we are getting it is x is here and x is here. So it is nothing but b beta plus c into x plus and terms containing y, that is a, and here it is c gamma plus c gamma into y plus and term containing z, that is a alpha plus and gamma is okay, where is that z? So yeah, here it is a alpha plus beta into z, and we are taking this is equal to a dx plus b dy plus c dz divided by lambda into ax plus by plus cz. Let's name it as equation number 2. Now I can write like this, provided my coefficient of x is here b beta plus c. So coefficient of here x is a, lambda into a. Provided I can write lambda a means equal to b beta plus c. Similarly, lambda b is equal to lambda into b is equal to a plus c gamma, and lambda c is equal to a alpha plus b. So by rearranging this, I'm getting so it is lambda a minus b beta plus c is equal to 0. Similarly, if I take this minus a plus lambda b minus okay, here it is minus, so it is minus c gamma is equal to 0, and similarly it is minus alpha minus b plus lambda c equal to 0. Now if you observe, this is a system of linear equation a b c. So using in matrix form, I have it is lambda minus beta minus 1 and it is minus 1 lambda minus gamma, and it is minus alpha minus 1, and it is lambda into column vector A, B, C, and which is equal to 0, 0, 0. Now, if you observe, this system has non-trivial solution only if the determinant of this matrix is equal to 0, and that is so determinant of this. Now, what is the determinant of this? Determinant of this is nothing but, so just apply the determinant formula, you will get it is a lambda into, so it is lambda square minus gamma plus minus of minus beta, it's plus beta into minus lambda and minus alpha gamma minus plus minus 1, so it is minus 1 into 1 minus plus alpha lambda, which is equal to 0. If the determinant of this is equal to 0, then this system has non-trivial solution. So by simplifying this, I will get it as lambda cube minus gamma plus beta plus alpha, that is alpha beta gamma, alpha plus beta plus gamma into lambda minus alpha beta gamma minus 1 equal to 0. Let me name this as equation number 4. Equation number 4. Now note that this equation number 4 is a cubic equation, so it has a 3 roots. Say let's roots are be lambda 1, lambda 2, and lambda 3. So corresponding to each of this lambda, my say this equation, say this is equation 3. So this equation corresponding to each lambda, equation 3 gives a non-trivial solution. Okay, getting? ಪ್ರತಿ ಲ್ಯಾಂಬ್ಡಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗಲೂ ನನಗೆ ಇಲ್ಲಿ 3 ಸೊಲ್ಯೂಷನ್ ಸಿಗ್ತಾ ಹೋಗ್ತದೆ. ಅಥವಾ ನೀವು ಇಲ್ಲಿ ಕೂಡ ಹೇಳಬಹುದು, ಇಲ್ಲಿಯೂ ಹೇಳಬಹುದು. Say those roots are, those solutions are with respect to lambda 1, like a1, b1, c1 are the solution. With respect to lambda 2, a2, b2. So with respect to lambda 3, a3, b3. So this is the cubic equation. It has the roots lambda 1, lambda 2, lambda 3. With respect to each lambda 1, lambda 3, the system has this as a solution. Say with respect to lambda 1, the solution is a1, b1, c1. With respect to lambda 2, the solution is a2, b2, c2. And with respect to lambda 3, solution is a3, b3, c3. Now using this three solution so this solution, that's a1, b1, c1, a2, b2, c2, a3, b3, c3. Using this three solution, my ratio that's there it is. Okay, this equation, this is already equal to this, so that a1, b1, c1 and lambda 1 will satisfy this also. So I have it is a1 dx. So it is let me write in general, ai dx plus bi dy plus ci dz divided by lambda I into ai x plus diy plus ci z, where I is equal to 1, 2, 3 with respect to a1, lambda 1, lambda 2, lambda 3. Now here I have three set of ratios, and they are equal. So I will consider two of them, that is a1 dx plus b1 dy plus c1 dz divided by lambda 1 into a1x plus b1y plus c1z, which is equal to again a2 dx plus b2 dy plus c2 dz into lambda 2 into a2x plus b2y plus c2z. Now This implies, so I'm writing the numerator as, so okay, let's separate this 1 by lambda 1 into the, I'm writing the numerator as d of a1x plus b1y plus c1z. Now the derivative of this is nothing but a1 dx, b1 dy, c1 z, and the denominator is as it is, that is a1x plus b1y plus c1z. Similarly here it is, it's 1 by lambda 2 into d of a2x plus b2y plus c2z divided by a2x plus b2y plus c2z. Now integrating, we will get it is 1 by lambda 1 into, now integration of this integration of function is its derivative is in numerator. So that is nothing but, you know this, it is ln of a1x plus b1y plus c1z. Similarly, in this side it's 1 by lambda into ln of a2x plus b2y plus c2z. So, and by a plus integration constant, let's say this is ln c1, where c1 is a constant. So by rearranging this, so this will come to the numerator, so I will get it is ln of a1x plus b1y plus c1z to the power 1 by lambda 1, and it is ln of, which is equal to, okay, and again ln of a2x plus b2y plus c2z to the power 1 by lambda 2 into c1. So again, by cancelling this, I can cancel this ln. Wait a second. Okay. By cancelling, simplifying, I will get it as a1x plus b1y plus c1z to the power 1 by lambda 1 is nothing but a2x plus b2y plus c2z to the power 1 divided by lambda 2 into c1. Now similarly by considering a1 dx, the other two ratios, that is a1 dx plus b1 dy plus c1 dz divided by lambda 1 into a1x plus b1y plus c1z is equal to a3 dx plus b3 dy plus c3 dz divided by lambda 3 into a3x plus b3y plus c3z. Solving this, you will get similar equation, that is a1x plus b1y plus c1z to the power 1 by lambda 1, which is nothing but a3x plus b3y plus c3z to the power 1 by lambda 3 into c2, a new constant. Then the integral. So the integral curves of the differential equation 1 are got by intersection of these two one parameter curve, or one family of one parameter of curves. These two curves, intersection of these two curves. Okay, so similarly we can solve the rest of the problems. Okay. Okay, let's continue now. So the next chapter is, it says orthogonal trajectories of a system of curves on a surface. Orthogonal trajectories of a system of curves on a surface. Okay. So given a surface f of x, y, z. So I have told in the beginning of this PVA introduction, we represent a point or a space or structure in a three-dimensional Cartesian coordinate system as a surface. So f of xyz is nothing but it's a surface and a system of curve on it. Right. We will find a system of curve which lies on one and cuts every member of the given system orthogonally. That means, say this is surface. So let me try to draw a surface. Okay. So let's change this color. Okay. So this is some surface, some kind of surface. Okay, so this is the surface f of x, y, z equal to 0, three-dimensional, and the system of curves. So then, and there is some system of curves. So let's represent it by some lines. Okay, there are some system of curves. So for a time being, I'm taking it as a line. They are the system of curves. Now, so we are finding the curves which lies on this surface, which cuts this curves orthogonally. ಅಂದ್ರೆ ನಾವಿನ್ನು ಏನು ಮಾಡ್ತಿದ್ದೇವೆ ಕೇಳಿದ್ರೆ ಇದೊಂದು ಸರ್ಫೇಸ್ ಕೊಟ್ಟ ಸರ್ಫೇಸ್ f of x y z equal to 0 and ಇದು ಕರ್ವ್ಸ್, ಈ ಕರ್ವ್ಸ್ ಈ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇರುವ ಕರ್ವ್ಗಳು. ಈ ಕರ್ವ್ ಅನ್ನು ನಾನು ಈಗ ಇದಕ್ಕೆ ಒಂದು ಹೆಸರು ಕೊಡ್ತೇನೆ. ಲೆಟ್ ಮಿ ನೇಮ್ ದಿಸ್ ಕರ್ವ್ as g of x y z equal to c and they are and it's also called as one parameter family of surfaces. ಓಕೆ, ಇದನ್ನು ಇನ್ನೊಮ್ಮೆ ನಾನು ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೇನೆ. ಓಕೆ, ಸೊ ಈ ಲೈನ್ ಗಳೆಲ್ಲ ಏನಂತ ಕೇಳಿದ್ರೆ, ಓಕೆ ಅದನ್ನು so this red is represents this equation and blue. Okay, where is this? This blue is nothing but this equation now. Okay, now ನಾನು ಆರ್ಥೋಗೋನಲ್ ಟ್ರಾಜೆಕ್ಟರೀಸ್ ಅಂದ್ರೆ ಇದರ ಮೇಲಿರುವ ಕರ್ವ್ಸ್ ಅನ್ನು ಫೈಂಡ್ ಮಾಡಬೇಕು. ಯಾವ ಕರ್ವ್ ಕೇಳಿದ್ರೆ ಅದು ಈ ಸರ್ಫೇಸಿನ ಮೇಲಿರುವ ಕರ್ವ್ಗಳನ್ನು ಫೈಂಡ್ ಮಾಡಬೇಕು. ಯಾವ ಕರ್ವ್ಗಳು ಹೇಳಿದ್ರೆ ಈ ಕೊಟ್ಟ ಈ ರೆಡ್ ಕಲರ್ ಕರ್ವ್ ಏನುಂಟು, ಈ ಕರ್ವ್ ಅನ್ನು ಆರ್ಥೋಗೋನಲಿ ಕಟ್ ಆಗುವಂತಹ ಕರ್ವ್ಗಳನ್ನು ಫೈಂಡ್ ಮಾಡಬೇಕು. ಸೊ ಲೆಟ್ ಮಿ ಡ್ರಾ ಇಟ್ ಬೈ ಗ್ರೀನ್. ಸೊ ದೀಸ್ ಆರ್ ದ ಆರ್ಥೋಗೋನಲ್ trajectories. These are the orthogonal trajectories. Okay. These are the orthogonal trajectories. ಈ ಸರ್ಫೇಸ್ ಮೇಲಿರುವ ಕರ್ವ್ಗಳನ್ನು ಆರ್ಥೋಗೋನಲಿ ಕಟ್ ಆಗುವಾಗೆ ಇರುವ ಕರ್ವ್ಗಳನ್ನೇ ಆರ್ಥೋಗೋನಲ್ ಟ್ರಾಜೆಕ್ಟರೀಸ್ ಆಫ್ ಎ ಸಿಸ್ಟಮ್ ಆಫ್ ಕರ್ವ್ಸ್ ಆನ್ ಎ ಸರ್ಫೇಸ್. So we are interested to find this. Okay, now let's first see the key part and let's then move to the problem. Okay, the tangential direction to the curve through the point. Say no. Okay, now let's change color. Let's take now. Yeah, let's take green. Okay, pink. Okay, now. Let's draw. Okay, let's draw a point. Let's draw a point. At this point, we say x, y, z. X, y, z. Now, ಈ x, y, z ಗೆ ಈ x, y, z ಈಗ ಅಂದ್ರೆ ಇಲ್ಲೇ ಆಗ್ಬೇಕು ಅಂತಲ್ಲ. ಇಲ್ಲಿದ್ರು ಕೂಡ ಇದು ಈ ರೆಡ್ ಕಲರ್ ಲೈನ್ ಇಲ್ಲೂ ಇದೆ, ಈ ಗ್ರೀನ್ ಕಲರ್ ಲೈನ್ ಇಲ್ಲೂ ಇದೆ. ಇಲ್ಲೇ ಆಗ್ಬೋದು, ಇಲ್ಲೇ ಆಗ್ಬೋದು, ಇಲ್ಲಿ ಇದೆ. ಸೊ ನಾನು ಒಂದು ಪಾಯಿಂಟ್ ಈ ಸರ್ಫೇಸ್ ಮೇಲೆ ಎಲ್ಲೋ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಲೆಟ್ ದ ಪಾಯಿಂಟ್ ಬಿ x, y, z. Now the tangential direction to the curve through the point. ಅಂದ್ರೆ ಈ ಕರ್ವ್ ಉಂಟಲ್ಲ, ಈ ರೆಡ್ ಕರ್ವ್ ಗೆ ಕರೆಕ್ಟ್ ನೋಡಿ, ಈ ಈ ರೆಡ್ ಕರ್ವ್ಗೆ ಟ್ಯಾಂಜೆನ್ಷನಲ್ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ಹೇಳಬೇಕು such that it lies on the surface. So ಈಗ ನಾನು ಇದಕ್ಕೆ ಹೇಳಿದ್ರೆ ಅದು ಎಲ್ಲಿ ಹೋಗ್ತದೆ? ಟ್ಯಾಂಜೆನ್ಷನಲ್, ಇಟ್ಸ್ ನಾರ್ಮಲ್ ಮೀನ್ಸ್ ಈ ಕರ್ವ್ಗಳಿಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಹೀಗೆ ಟ್ಯಾಂಜೆಂಟ್ ಗಳನ್ನ ಹಿಡಿಬೇಕು. ಕರ್ವ್ ಪಾಸ್ normal to or normal to this curve. Okay, and let's name this as dx comma dy comma dz. So now if you observe this, so this will lies on the surface. So since it is lies on the surface, it will satisfy these two equation, that is with respect to one, that is let's name this as 2. So with respect to 1, it will satisfy dou f by 2x into dx plus dou f by 2y into dy plus dou f by dou z into dz equal to 0, and with respect to this 1 kilometer family of curve, dou g by 2x into dx plus dou g by 2y into dy plus dou g by dou z into dz equal to 0. Okay, now let's come here once again. So ಇಲ್ಲಿ c ಇದೆಯಲ್ಲ, ಯಾಕೆ ಈ c ಅಂತ ಹೇಳಿದ್ರೆ ಈ c ಇದೇನೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ ಇಲ್ಲಿ ಇರುವ ಈ ಕರ್ವ್ಗಳು. ಸೊ ಈ ಕರ್ವ್ಗಳು ಪ್ರತಿ ಇಲ್ಲಿ ಕೂಡ ಇದೆ, ಇಲ್ಲಿ ಕೂಡ ಇದೆ, ಇಲ್ಲಿ ಕೂಡ ಇದೆ, ಪ್ರತಿಯೊಂದು ಇದರಲ್ಲಿ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಎಲ್ಲ ಅದರ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಸೊ ಅದನ್ನು ಈ ಸಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ. ಇಟ್ಸ್ ಅ ಪ್ಯಾರಾಮೀಟರ್. ಸೊ ಒನ್ ಪ್ಯಾರಾಮೀಟರ್ ಫ್ಯಾಮಿಲಿ ಆಫ್ ಕರ್ವ್ಸ್. ಸೊ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಕೇಳಿದ್ರೆ ಇಟ್ಸ್ ಅ ಫ್ಯಾಮಿಲಿ ಆಫ್ ಕರ್ವ್ಸ್. Okay, now let's move forward. So using these two equation, now using rule of cross multiplication. So ಇಲ್ಲಿ ಎರಡು expression ಇದೆ, like a1x plus b1y plus c1z and a2x plus b2y plus c2z. So using my rule of cross multiplication, so what is dx? dx by dou f dou y, dou f divided by dou y. How it is works? Okay, so let's write here. Say suppose you have like this, a1x plus b1y plus c1z equal to 0, and a2x plus b2y plus c2z equal to 0. Then rule of cross multiplication says x divided by b1 c2 minus b2 c1 which is equal to y divided by a2 c1 minus a1 c2 which is equal to z divided by a1 b2 minus a2 b1. So using this rule, let's write this is equivalent to so okay, so this is equivalent to dou f by dou y into dou g by dou z minus dou g by dou y into dou f by dou z which is equal to next again dy divided by dg by dou g by dou x and dou f by dou z minus dou f by dou x dou g by dou z which is equal to dz divided by dou f by dou x into dou g by dou y minus dou f by dou y into dou g by dou x. Yes, these three ratios are equal. That is dx by p which is equal to dy by q, which is equal to dz by r, where what is p? P is nothing but this expression, q is nothing but this expression, r is nothing but this. So I'm not writing once again what it is, so you can clearly able to see from the board. Okay, now the curve. So let's move again. So ಈಗ ಈ ಪಾಯಿಂಟ್ಗೆ ನೀವು ಈ ಪಾಯಿಂಟ್ಗೆ ನಾನು ಇದು ಸರ್ಫೇಸ್ ಮೇಲಿರುವ ಕರ್ವ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿ ಆ ಕರ್ವ್ಗೆ ಟ್ಯಾಂಜೆಂಟ್ ಹೇಳ್ದಾಯ್ತು. ಇನ್ನು ಇದೇ ಪಾಯಿಂಟ್ಗೆ ಆರ್ಥೋಗೋನಲ್ ಟ್ರಾಜೆಕ್ಟರಿ, ಯಾವುದು ಆರ್ಥೋಗೋನಲ್ ಟ್ರಾಜೆಕ್ಟರಿ? ಈ ಗ್ರೀನ್ ಲೈನ್, ಈ ಗ್ರೀನ್ ಲೈನ್ ಉಂಟಲ್ಲ, ಇಲ್ಲಿಂದ ಈ ಗ್ರೀನ್ ಲೈನ್ ಗಳನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿ ಅದಕ್ಕೆ ಆ ಗ್ರೀನ್ ಲೈನ್ಗೆ ಒಂದು ಆರ್ಥೋಗೋನಲ್ ಟ್ಯಾಂಜೆಂಟ್ ಅನ್ನು ಎಳಿಬೇಕು. ಅಂದ್ರೆ ಟ್ಯಾಂಜೆಂಟ್ ಅನ್ನು ಎಳಿಬೇಕು, ಆರ್ಥೋಗೋನಲ್ ಅಂತಲ್ಲ, ಟ್ಯಾಂಜೆಂಟ್ ಆರ್ಥೋಗೋನಲ್. ಓಕೆ, ನಾವು ಇದಕ್ಕೆ ಹೇಳಿದಾಗ ಇಟ್ ವಿಲ್ ಬಿ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಲೆಟ್ ಮಿ ಡಿನೋಟ್ ಇಟ್ ಬೈ dx dash, dy dash and dz dash. Moreover, okay, let's see that again. So dz. So again, this is again lies on this surface. Hence it lies on the a surface that it satisfy the first equation, f of x y z equal to 0. Therefore I have dou f by dou x into dx dash plus dou f by dou y into dz dy dash plus dou f by dou z into dz dash equal to 0. Now also you observe in this these two tangents are orthogonal. That means these two vectors are orthogonal. When these two, let's say three tuple vectors are orthogonal, we have their dot product is 0, and what is that? It is nothing but dx dash plus dy dash plus dz dash. They are equal to 0. They are equal to 0. So let's name. Okay, now we have left something naming. So let's name it as 5 and let's name it as 6. Okay, now using see this. Okay, so since these three are equal, my dx is directly proportional to p. Moreover, using this we get p into dx dash, because dx is directly proportional to p. So I can replace it by p dx dash plus, again this is by q dy dash plus this by r dz dash is equal to 0, because these three ratios are equal. Say take it is equal to some L, then dx is nothing but nothing but p into L, which implies dx is directly proportional to L. Similarly, dy is directly proportional to q, dz is directly proportional to r. So here see, here dx is directly proportional to p, so I am replacing it by p. So p dx dash plus q dy dash plus r dz dash is equal to 0. Means all the ratios are equal. I am getting this equation. Now, so let's name it 7. Equation number 7. Now, using this 5 and 7, applying again the rule of cross multiplication, you will get dx dash. Now, how to write dx dash? Divided by dou f by dou y into r. So it is dou f by dou y into r minus dou f by dou z into q. Dou f by dou z into q, which is equal to dy dash divided by p into dou f by dou z, or like dou f by dou z into p minus dou f by dou x into r which is equal to dz dash divided by dou f by dou x into x into q minus dou f by dou y into p. Now okay, now let's rewrite it as dx dash by p dash, which is equal to dy dash by q dash, which is equal to dz dash divided by r dash, where p dash is this expression, dash is this expression, and r dash is this expression. Okay, now we name it as, let's name it as 8. Okay, now the solution of this equation, this differential equation, this integral this equation, this differential equation, the solution of this differential equation gives the system of orthogonal trajectories. System of orthogonal trajectories. Okay, yes, let's now. So let's be in with a problem. So consider find the orthogonal trajectories. Find the orthogonal trajectories on the cone. So here the cone is mentioned as x square plus y square, which is equal to z square into tan square alpha, where alpha is some fixed quantity. Alpha is fixed, and of its intersection with family of planes, with the family of planes parallel to z equal to 0. Okay. Okay. Now we need to find the orthogonal trajectories. So before that, let's draw this cone. So it will be something like, say, again it is not perfect. So let's try to draw it in a perfect manner. Okay. So this is z axis, say this is x axis, and say this is y axis, and this is the cone. This is a cone, x square plus y square, which is equal to z square tan square alpha. Okay, now, and it also given that which are the curve. There is a curve with of its intersection with the family of planes. Parallel to z equal to 0. Now what is z equal to 0? Z equal to 0 means this is the plane, E plane. Z equal to 0 andre E plane. Okay, this is the plane. Okay, E plane ಗೆ ಪ್ಯಾರಲಲ್ ಆಗಿರುವ ಪ್ಲೇನ್ ಗಳು ಯಾವುದಿಲ್ಲ. ಇದನ್ನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಈಗ ನೀವು ಈ ಕೋನ್ ಅನ್ನು ಅದನ್ನು ಸರಿಯಾಗಿ ತುಂಡು ಮಾಡ್ತಾ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ ನಿಮಗೆ, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಸಿಗ್ತಾ ಹೋಗ್ತದೆ, ಸರ್ಕಲ್ ಸಿಗ್ತಾ ಹೋಗ್ತದೆ. ಸೊ ಲೆಟ್ಸ್ ಡ್ರಾ ಇಟ್ ಬೈ ಕಲರ್ಡ್ ಲೈನ್. ಸೊ ದೀಸ್ ಆರ್ ದ, ಈ ಪ್ಲೇನ್ ಅನ್ನು ಕಟ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ನಿಮ್ಗೆ ಹೀಗೆ ಸರ್ಕಲ್ ಸಿಗುತ್ತೆ. ಇದನ್ನು ನಿಮ್ಗೆ ಹೀಗೆ ಮಾಡ್ಬೇಕಂದ್ರೆ ಹೀಗೆ ಸರ್ಕಲ್ ಸಿಗುತ್ತೆ. So let's draw it nicely. ಈ ತರ ಸರ್ಕಲ್ ಗಳು ಸಿಗುತ್ತೆ. ಓಕೆ, ಯಾ. ಈಗ ಆರ್ಥೋಗೋನಲ್ ಟ್ರಾಜೆಕ್ಟರಿ ಅಂದ್ರೆ ಏನು? ಟ್ರಾಜೆಕ್ಟರಿ ಇದನ್ನು ಆರ್ಥೋಗೋನಲಿ ಕಟ್ ಆಗುವಾಗಿರುವ ಕರ್ವ್ಗಳು, ಅದನ್ನೀಗ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಸೊ ಲೆಟ್ಸ್ ಮೂವ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು our theory part. So given that the family of curve was this, and okay, now what is this ಇದನ್ನ ಕಟ್ ಮಾಡೋ ಪ್ಲೇನ್ ಗಳು ಯಾವುದು? that ಆಗ ನಾವು ಬರ್ತಿದ್ದಾಗೆ g of x y z equal to c ಇಲ್ಲಿರುವುದು ಯಾವುದು? that is nothing but ಇದಕ್ಕೆ ಪ್ಯಾರಲಲ್ ಆಗಿರೋ ಪ್ಲೇನ್ ಗಳು ಅಂದ್ರೆ z equal to c. ಈ ಸೇಮ್ ಏರಿಯಾದಾಗಿ ನಿಮ್ಮ ಪ್ಲೇನ್ ಇದನ್ನು ಕಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತದೆ, ಆಗ ನಿಮಗೆ ಈ ಸರ್ಕಲ್ ಗಳು ಫಾರ್ಮ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಓಕೆ, that's fine. Now so this is my f of x y z equal to 0, and this is my g of x y z equal to c. So using this we are writing the family of curves are characterized by the pair of equation, that is equation x square plus y square plus is equal to z square tan square alpha, and one more is z is equal to c. From this we are writing family of curves characterized by the pair of equation. Just ಇದನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಾ ಬರೀರಿ. ಸೊ ಇದನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಏನು ಸಿಗ್ತದೆ? It is 2x plus 2x dx plus 2y dy plus is equal to 2z tan square alpha into dz, and ಇದನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ it is z dz equal to 0. So using this, ಇಲ್ಲಿ ನನಗೆ 2 1 ಕಾಮನ್, so delete ಮಾಡಬಹುದು, so cancel ಮಾಡಬಹುದು. So it is x dx plus y dy, and if I rearrange it, it is minus z tan square alpha dz equal to 0, and this one I can written as 0 into dx plus 0 into dy plus 1 into dz equal to 0. Now this is again, as per the theory, this is then equivalent to dx divided by, using the rule of cross multiplication, we are getting y into 1 minus 0 into anything, so it is 0, I am not writing, so it is equal to dy divided by 0 into this, okay, 0 minus 1 into x, so it is minus x, so and it is dz divided by x into 0 into y, so both are 0, so it is divided by 0. Now the system of equation, where is, now this is acting as p dash, q dash, r dash. So using this I am writing now the new equation. This is now p q r. Using this writing the orthogonal system of orthogonal trajectories determine the pair of equation. That is, the first is this one is x dx plus y dy minus z into tan square x dz equal to 0, and another one is now y dx minus x dy plus 0 dz, y dx minus x dy 0 as per which is equal to 0. That is the theory part. Yeah, from this how you let know what is the PQR and then ಹೇಳ್ಬಾರ್ದು, ಅದೇ ರೀತಿ ಅದನ್ನೇ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರು problem. Now using this, now find what is dx. So now dx dash till now ಇಲ್ಲಿ ಹೋಗ್ತಾ ಇಲ್ಲ, we are just going to the dx only. So again, using rule of cross multiplication, what is dx divided by, so it is y into 0 minus x into z, so it is minus x into z tan, so minus x plus x into z into tan square alpha, which is equal to dy divided by y into minus z, so it's minus y into z tan square alpha, and this one is 0, okay, no problem. So it is again is equal to dz divided by x into, so it's minus x square, and y into, so it's okay minus y square. Now if you also, there is a minus in all the denominator, so we are just rearrange it, you will get it as dx divided by, so it is x z tan square alpha, which is equal to dy divided by y z tan square alpha, which is equal to dz divided by x square plus y square. Let me name it as equation number 5. Now using the now we have to solve this, but we have to solve this, we have already seen there are 3 methods, so just use one of the method. Okay, now so first I will use multipliers x y and minus z tan square alpha. So get numerator as x dx plus, and using this multipliers we are writing the equation, and this that ratio is equal to ratio 3, these three ratio, x dx y dy minus z tan square alpha dz divided by, now when I write multiply with this with x, I will get it is x square z tan square alpha. When I multiply this with y, I will get plus y into y square z tan square alpha. So when I multiply with this, I will get it is minus z x square tan square alpha minus z y square tan square alpha. I just listed it. Now if you observe, this is this cancel with this is cancel with one and other, so I'm getting this denominator is equal to 0. So I'm getting x dx plus y dy minus z tan square alpha dz equal to 0. So by integrating this, by integrating this we get it is x square by 2 plus y square by 2 minus z square by 2 tan square alpha. It's a constant, so it's equal to some constant c1. C1 now by rearranging with this 2 is cancelling, so it is x square plus y square and minus z square tan square alpha equal to 2 into c1. I will just name this c1 star, then this c1 is nothing but 2 into c1 star. Okay, so now, so yeah, if you observe, we are getting once again we are getting the same equation, and this is let's take it, the c1 is equal to 0. We are just taking the c1 is constant. Let's take it as c1 is equal to 0. Okay, now moving further now compare these two ratios. I will get okay, let's, yeah, that's what here itself. Comparing these two ratios, that is dx by xz tan square alpha, which is nothing but which is equal to dy by yz tan square alpha. Now then z cancel, tan square alpha cancel, so it is nothing but dx by x is equal to dy by y. So integrating this, you will get ln x is equal to ln y plus some constant. I will take it as ln c2. So by rearranging, it is nothing but ln x, which is equal to ln y c2. That is again it is x is equal to y into c2. X is equal to y into c2. Hence, the orthogonal trajectories are formed by intersection of this equation. Okay, wait a second. So it's okay. So the orthogonal trajectories are formed by intersection of this equation and this equation. Now, what is this equation? This is nothing but our cone itself, and this equation is nothing but, if you observe, they are nothing but you got this as x is equal to y into c2. So if you observe, if y is c2, x is 0, so there are the lines passing through this origin. So you will get so if I draw it by this red lines, so I will draw this equation by red lines. They will be something like this. Okay, so there the equation. So it says, yeah, the orthogonal trajectories are nothing but they are the intersection of this equation and this is nothing but the equation, the curves on this curve. They are nothing but the perpendicular curve, orthogonal trajectories. Hence the answer. So, thank you.